Hello, hi, good evening, everyone. Good morning if you're joining from some other location. So thank you so much for taking out time on Saturday to join this meetup. This particular meetup, we will be focusing on specifically KSQLDB. So it is something required, like like there are certain prerequisites for understanding the technical aspects of this particular meetup. You should know Kafka. So I just want to quickly check Rama, Prashant, and others, like, do you have any background in Kafka, or what do you do with KSQLDB right now? If you are having any projects going on, or like, are you working with KSQLDB or any other streaming SQL technology? If you can share, then it will help me a lot to get your background. Okay, so you can type on chat or you can unmute yourself and share your thoughts. The whole idea here is to have interactivity throughout the session rather than just becoming a webinar kind of one-way communication. Yeah. So let's get started. We are having a topic today, which is KSQLDB. Now, the question is, what is KSQLDB? So KSQLDB is something which is open source, and it is streaming SQL engine. So what is streaming SQL engine? This is like unbounded streams of unbounded data, you can say. Lot of events are coming and we are processing those events. We can query those events. We can transform those events. We can enrich those events. So a lot of things can be done. And this is streaming, which is moving data, unbounded data set. And this is a SQL engine. So overall, this is helping us in implementing streaming pipelines in seamless manner. So I will talk about this in more detail. But right now, since we are just getting started, so I want to talk about, like, it is an open source technology and it is streaming SQL engine. So it started in like May 2017 or so. During that time, it was announced in Kafka Summit. And after that, 2019, it was renamed to KSQLDB. Earlier, the name was KSQL. And then it was renamed to KSQLDB in 2019. And the reason for renaming this KSQL to KSQLDB is there are a lot of functionalities which are added into KSQLDB. I will talk about those. So let's see, why do we need KSQLDB? So very first thing is you can perform real-time querying on KSQLDB. So that is like one important aspect, real time. So you can query the data, you can process the data, you can transform the data, and the data which is present on Kafka. And Kafka is like kernel of big data projects or event-driven projects, like event-driven applications. You will find Kafka is backbone of those projects. And KSQLDB helps in querying the data which are like which is stored on Kafka cluster, or like which is being streamed. Because let's say we take one example. Let's say you have an event streaming application. For example, let's say we have an application which is like movie ratings. So you are giving ratings to movies and events are being generated. So those events will go into Kafka topics and we can process the data. We can analyze the data on the fly and we can store it back to Kafka. We can perform aggregations. We can persist that data into Kafka cluster. And I will also talk about some interesting things like materialized view, how they help and how can we query those materialized views. But in general, if you see, like this is for real-time querying and processing data on Kafka. So this is distributed in nature. That means it is horizontally scalable, and you can divide and conquer. So if you have a lot of data, the data velocity is very high, then KSQLDB can help you in processing that data which is moving. So I just talked about high scalability, and then automatic load balancing and fault tolerance or failover. This is something which is like inherent nature, and KSQLDB servers, if anything fails there, then it does not impact the overall the processing. So it will keep on executing your workloads or your queries without giving any problems as such, like it is fault tolerant. Apart from that, it can handle stateful queries. So I will talk about what are stateless queries, what are stateful queries. But it is something like, let's say you are performing joins. Let's say you are performing joins. You are performing some aggregations. You are performing some windowing operations. So there can be many things which are stateful in nature. State, we have to maintain the state, we have to remember. Yeah. So if you are joining two different two different topics, let's say in Kafka you have data in one topic. Let's say you have data for let's say drivers, and you have data for their location. So let's say I take one example. Let's say this is my Kafka cluster, and in Kafka cluster I have a topic. This is topic 1, and let's say topic name is, driver. And we have another topic, topic 2. This is driver profiles, and this is driver positions. Let's say we are getting data from sensors of the car. So let's say we created a pipeline. So this is my Kafka cluster. This is Kafka cluster. And we have data here. Let's say this data is like this. We have data here in a system, let's say relational database system. This is RDBMS. And we are having Kafka Connect here. So this is another cluster in between, let's say. And this Kafka Connect is bringing data. This is Kafka Connect cluster. Kafka Connect cluster. And we are bringing data inside the Kafka topic like this. And we can have another pipeline, very simple pipeline, where you have, let's say, this is another Kafka Connect cluster, or you can say connector. We can run multiple connectors in the same cluster. So let's say we have this connector, another connector in the Kafka Connect cluster, Kafka Connect. And then we have another system here. Let's say we have MQTT protocol and MQTT proxy, and through that we are ingesting data. So based on that, let's say we have sensors, and sensors are sending reading. So this can be another source. So these sensors are in cars, and Audi is one of the very big customers for Confluent, and we can ingest data through this. So this is MQTT protocol being used, and it is being ingested. So we are getting streaming data. So this is coming from relational database, because this is like a master data for drivers, master data for drivers. And here, this is our data, which is constantly being streamed, and it is being stored in the topic. Now we want to join these two data sets. So this is one of the use cases where Kafka SQL, like 𝐜𝐭𝐴𝐶QLDB will help you in firing queries, and it can be done on the fly. That means like the query will keep on running, and it will keep on enriching the stream. So this is also called enrichment, stream enrichment. This is called stream enrichment. And we are joining these two things, because a lot of times it happens that in an enterprise, one single source cannot help us in giving insights. So you have to join data from multiple sources. So these two different sources, we are joining data together, and then we are able to gain insights. So here we can detect a lot of things, like we can detect accident happened or not, right? We can even detect if there is any fault in the vehicle, or lot of insights can be gained, and we can send alerts to the owner of the car, right? So a lot of things can be done after doing this join. So this is like typical pipeline that we used to do, typical pipelines that we used to develop since Kafka Connect started, like 2015 when it started. Then a lot of connectors started a lot of connectors were added into Kafka ecosystem. And now we have Confluent Hub, where you will find lot of lot of connectors there. So we have already taken one meetup on Kafka Connect in case you are interested to know about it, like how Kafka Connect works. So you can simply go to the YouTube channel and you can type here Kafka Connect, and here you will find a video getting started with Kafka Connect. It's like 1.5 hours video. You can just go through it and you will understand how Kafka Connect actually works. So coming back to this, we are talking about KSQLDB, and I was referring to a scenario where we can handle this stateful queries. I was talking about stateful queries, and there I started to explain that when you have when you have streaming data and you are enriching streams, or you are joining this was one example, and then you are performing aggregations, right? So you want to find out how many iPhones are sold at a particular instance in time. So that is a state that you have to maintain, and this is aggregated data that we can keep in KSQLDB. That's why we call it DB, database. So we can perform windowing operations through windowing operation. Like, what is a window? So we can define a logical view of data through which we can get to know, like, in last 5 minutes, what was the movement of the vehicle. Based on that, you can identify like whether there is a fault in the vehicle, or maybe you want to see like if someone is doing rash driving or not. So a lot of insights can be gained if you apply windowing operation. So I'll show you. I have one demonstration also in one of the videos. I will show you that video where you can watch how do we do windowing. And then we have SQL-like syntax. That means anyone who is aware about SQL can work with KSQLDB. So this is very easy interface to process and analyze data in real time. It supports materialized views. So I will talk about materialized views in detail. This will take maybe 10 minutes or 15 minutes before we reach here. So it also allows us to perform interactive queries. You can fire the command, you can see the result. So this is like CLI, command line interface, or you can have user interface, or you can have REST-based API. So there are a lot of ways through which you can interact with KSQLDB. These are kind of clients of KSQLDB cluster. So having support for connectors to simplify data pipeline. So we will look into that. Like, what are these? So there are a lot of things which may not be clear right now. Don't worry. But as we move forward, and then we will be able to focus on each and every point that we have mentioned here. No need for Kafka Connect cluster. So right now I talked about one scenario where I was talking about Kafka Connect cluster. Yeah. So this is Kafka Connect cluster, which is old way. Definitely these clusters are very common these days also. It's not completely removed, but moving forward you will see KSQLDB also started to add a lot of capabilities related to connecting to sources, but number of connectors are very less right now in KSQLDB. I will talk about these things, like how KSQLDB simplifies the data pipelines. So if you go back now, we were here, we were talking about simplifying data pipelines. We will spend some time here, and there is no need for Kafka Connect cluster if you have, right now, limited support is there. Right now, limited support is there. Okay, so now any questions till now? If you have anything in your mind, please feel free to unmute yourself and clarify, like why we are talking about KSQLDB. You may be having questions like, what is the difference between KSQLDB and K-streams, or KSQLDB versus Spark SQL? So you may be having such kind of questions. We will discuss these things during the session. But this is one technology that helps in doing a lot of things around, like it is simplifying overall streaming architectures. Because in streaming architectures, you have to ingest events, you have to store events, you have to process events. So I will write down storage is happening in Kafka. So I'll say ingestion is part of that. Ingest events, you have to process events, you have to analyze events, right? And then you have to maybe processing transformation is similar thing. So I will not write like that, but you have to query events, right? So you have to query a state, you have to query a a particular instance in time, what is the current state, right? So you want to query. So we can create those materialized views. So from that perspective, yes, storage can be written here from materialized view perspective, but it is all backed by Kafka. Okay, so if you have any questions till now, feel free to clarify and unmute yourself, yeah? Or you can ping on the chat. Okay, now the question is, why do we need KSQLDB? So let me show you something interesting here. So I'm going to KSQLDB official website. Okay, now this particular technology specifically is built on Kafka, and we have real-time event processing capability. So if you see in KSQLDB, you are able to use SQL and you are able to connect with external sources. So this is like one way to capture the events. You can integrate KSQLDB with external sources. For example, JDBC source is supported and limited number of sources are supported, but this is one example. How do we connect with any database and gather the data from there and generate events and bring it inside the Kafka? So this is one connector. And after that, you are able to transform the data. So you can see we are able to transform the data. You are able to calculate the distance, right? So you are able to perform continuous transformations. Continuous transformations means like the data is constantly flowing and you can perform transformations. And after that, you can create a table. I will talk about what is a stream and what is a table. I will talk about it. But this is a source connector because we are connecting with the source system and we are bringing data inside KSQLDB. So this is stream and this is table. And in this table, we are creating a materialized view. So what is materialized view? That is very first question because it is the term is coming again and again. So I want to clarify that before we move forward. So very first thing is this materialized view is something which is like a pre-computed or pre-aggregated data. So if you want to get the insights, let's say you want to get summary of your data, let's say monthly report or weekly report or maybe yearly report. So you have pre-aggregated data, right? So when you fire the query, let's say you want to see the report. You want to see the report. When you fire the query, then it should basically give you the result instantaneously. It should be very fast. So the views which are created within KSQLDB, those are called materialized view, and these materialized views are like read optimized version of your data. That is a simple definition of materialized view. What is a view? It's basically materialized. That means it is keeping the data. It is ensuring the data is always up to date. Kafka is doing that, like KSQLDB is doing that. And that view is giving you the pre-computed result, which is already stored, right? So this is a kind of cache, you can say. And it's a place where the results of the queries are pre-computed and they are stored for fast access, right? So when you fire the query, then you can get the results from the materialized cache. Yeah. So this is the thing. But in case of traditional databases, right? So there was a difference. Like in traditional databases, we have to maintain it. Like if there were other cases, like indexes were there in traditional data, but here indexes are there in traditional databases. But here, it's not in that. There is no concept of indexes. Yeah. So here we are when we are writing the data, then we are keeping that materialized view up to date as such, right? But here, when you fire the query, the results are very, very fast. So this is materialized view. We can create it in KSQLDB and we can also perform lookups. So when you fire such queries, like you are looking for a specific row in that materialized view that you created, this table that you are creating, then you can get the results very fast, yeah, in real time, even if you have petabytes of data. Yeah. So that's the idea here. So now I want to show you something very interesting. This is one of the presentations on SlideShare. And if you go inside this presentation, you will see what is the difference between KSQL? This is not KSQL now. It is called KSQLDB. It has been renamed. So we can fire such queries and we can find out like the payments which are fraudulent, the transactions which are fraudulent, right? So using just simple queries, you are able to gather this insights. Otherwise, if you have to write it in Kafka streams, then it is going to be a lot of code. So this is a difference. And I also want to show you another thing. Like here we have like without KSQLDB. This is with KSQLDB, and this is without KSQLDB, right? So there is a difference. You have to build the application, you have to submit the job, and you have to store the results. So this is cumbersome. But KSQLDB, you can just simply write a SQL statement. So it is so easy. So KSQL can be used for multiple use cases. You can say it can be used for data exploration, data enrichment, streaming ETL, filter cleans, masking the data, real-time monitoring, anomaly detection. A lot of use cases it can be applied. And I have just shared one example on the whiteboard where I was talking about streaming enrichment, data enrichment. Yeah. So this is change data capture use case where KSQLDB can be used, but let's switch back to the discussion that we were having. So there are many use cases where KSQLDB can be applied. Now, what is the difference between KSQLDB and Kafka streams? So very first thing is KSQLDB, you are writing SQL-like syntax. You are able to process, analyze. You can create materialized views. You can connect with external systems, like if connector is there, using SQL-like statement. But in K-streams, you can use only domain-specific language, and this is processor API. So this is functional and imperative, and this is like requiring coding. You need developers to write code. Here, even analysts, the people who are having high-level knowledge, they can work with KSQLDB. Here, productivity is more because you must have seen in the previous one, like when we went there. Sorry. So let me go to the slides here. If you go back, you'll see in the previous case we were looking at the number of lines of code that we have to write. A lot of code we have to write. But here the productivity is less because you have to write a lot of code. So here we have less control flexibility, but we have full control over events. It requires separate cluster. There is no need for separate cluster. And there are lesser data formats supported. Any data formats can be used here. No programming in Java, Scala. You don't have to go through the development life cycle. But here you need to use Java, Scala API. Here it is very much interactive querying and REST-based API. And here we have microservices-based application, no REST-based interface. You have to build your own REST-based interface. So I hope you are getting some clarity that K-streams, because we had a meetup earlier on K-streams, and during that meetup, introduction to K-streams was covered, but this is like comparison between KSQLDB and K-streams, which is a new topic. We had a couple of meetups on KSQLDB also, where we had a lot of hands-on. I did real-time streaming, clickstream analysis using KSQLDB in one of the meetups. And I will give you that video also. It's there on our YouTube channel, where you can watch and understand how we can perform all these things in like the real-time processing we can perform through KSQLDB. But today's meetup, since we got a lot of inputs, like initially we did not explain why KSQLDB and what is KSQLDB and how it is different from KSQLDB and K-streams. So we got those inputs. So we thought, like, why not we do a meetup on this particular aspect, and then later on you can watch that video where we have covered a lot of hands-on. Okay, so after this, which one will you prefer? Yeah, so this is the video, and the video is real-time clickstream analysis using KSQLDB. You can watch this video. I will show you when I'm giving walkthrough on screen. So which one will you prefer? Any thoughts, like which one will you prefer when we have this? Which one is preferred? KSQLDB. Okay, reason why will you prefer KSQLDB? I'm getting some responses on private chat, so that's why I'm just checking. Okay, why will we prefer KSQLDB? Any reason for that? Less coding, very good. Yes, KSQLDB is less coding. What else? SQL-like less line of code, absolutely. And um, we have SQL-like syntax, easy to check, validate data. Okay, now easy to query. But KSQLDB has limitations, like K streams is lower level. So if you see, there is a pyramid. If you just look at it, there is a pyramid. So this one is producer consumer API in Kafka. This is producer consumer API in Kafka. Or this one is K streams API in Kafka. And this one is KSQLDB. This one is least coding. So this is like least flexible. Here, this is like most flexible option. This one is most productive, like you can like achieve more. Yeah, so this is like productivity is high. Productivity is high, highest here. And here the productivity is lowest. Yeah, so you can see it shows that the functionality which is available in producer consumer API are more compared to like K streams, and then KSQLDB is having lesser functionality compared to other two. Yeah, so these are three options very commonly used while working with Kafka. So we can prefer Kafka streams. This is preferred when you are building some maybe microservices based application. It is preferred for microservices based apps. And you need low level control. Let's say you want to work closely with your state store. Yeah, so then you can use processor API. Yeah, and then you can punctuate events, so you get more control on the events when you are using K-streams API. Yeah, so if you have a team which is having a skill set related to working with JVM applications, then you can go for this particular thing, right? So but we always say that start with KSQLDB, and later on, if required, you can build your UDFs, user defined functions. If let's say user defined functions will not help, then you can switch to K-streams API. Now there is another question, like before I move forward, if you have any questions anytime, you can unmute and clarify. So there is another question, which is what is the difference between KSQLDB and Spark SQL? Please understand, it is something we are comparing apple and orange. It is not same, even though you will say Spark SQL, Kafka SQL DB. So it's not same. These are two different technologies, and even the purpose is different. Yeah. So we can make UDFs in KSQLDB, but you have to write code. Like developers have to write code, build the jar, and then it will work. Yeah, so that is possible. Now, KSQLDB is basically for streaming applications, a database for streaming processing applications. So when I say database for streaming processing applications, that means you can build your materialized views, you can store those, you can query data, you can perform lookup queries, yeah, and you can connect with external systems. So it is giving you an ecosystem overall to simplify your data pipelines. So if you look at the flow, if I show you, let me, you are simplifying overall pipelines. So if I show you the flow, you are able to perform ingestion of events, you are able to perform transformation of events, you are able to persist those like views, and then you are able to query. So all these things are possible. Okay, so it means that all view in Kafka is materialized. Okay, so here when we talk about KSQLDB, we are talking about materialized views. Yes, because when you because we are talking about read optimized data, we will be firing queries and we want real-time response. So you can say yes. The answer to your question is yes. In Kafka's KSQLDB, specifically when we are talking about materialized views, then we are talking about persisted views which are materialized only. And here we are just ensuring that the data is as per the requirement of the queries that we will be firing. Yeah, so that the read time is the least. Yeah, that's the idea here. Okay, so now this is clear that KSQLDB is not just for processing your data, because Spark SQL is purely for processing or analysis of your data. It's not for storage. Spark is not for storage. Spark is not for ingestion as such. Yeah, but we have data source API through you can integrate systems, but it's not primarily for ingestion as such here. And apart from that, there is a dependency on Kafka. Yeah, and this one is not dependent on Kafka. Yeah, and it bundles a lot of features needed for streaming applications that I was talking about. Yeah, but it is primarily for batch, but structured streaming for streaming processing is there. And then we have exactly one semantic. It supports exactly one semantic, but here it supports at least one semantic, but you can integrate with Kafka to achieve exactly one semantic. Yeah, so there are many differences, but the key thing is here you are primarily focusing on integrating, applying Kappa architectures. Kappa architecture, if you are implementing, then it's good for that. But this one is like very commonly used for Delta architectures. In case you are not familiar with Delta architecture, Kappa architecture, you can watch these videos. I have created a lot of videos on the YouTube channel. If you just go here, you will find Kappa architecture, big data. You just search for big data architectures. You will understand like what is the difference between Kappa architecture and Lambda architecture. I think that video should be here. We can find out, but I can also show you Delta architecture. This is Delta architecture, getting started with Delta Lake. So we conducted a meetup where we covered this in very much detail. You can watch this offline at your own pace. So this is another interesting video on Delta architecture, how to get started with Delta Lake. Okay, so now what is the architecture of KSQLDB? So this is our Kafka cluster. So KSQLDB, it stores KSQLDB stores KSQLDB internal topics, for example, configs, etc. Yeah, so we have here Kafka cluster, which is a durable storage. This is a durable storage. And this durable storage has all the configuration. So here we have the internal topics and configs. So we have this Kafka cluster, which is acting as a durable storage. So this is like having no dependency on any external database where we have to persist all the configuration. So we are keeping in Kafka cluster itself. Now KSQLDB cluster is having a lot of KSQLDB servers. Yeah. And we have an engine which is responsible for transforming the queries into the plan and then converting into code, and then finally the code executes, yeah, as K-streams applications. So I will show you how it actually works. So let me go to okay, so let me go to one blog where let's say we go here and you can see, let's say when you fire a query, this is from KSQLDB documentations. So using a query, you are able to find a fraud. So we are able to find out possible fraud. We are creating a table. I will talk about what is a table, what is a stream, don't worry. But here we are selecting card number count star and from the authorization attempt. So let's say whenever there is a successful or failure attempt, so whenever there is a failure attempt, then we are sending an event to a particular topic, let's say authorization attempt, and we have created a stream on top of it. So let's say the events are going into authorization underscore attempt topic in Kafka, but we are creating a stream on top of it so that we can use it in Kafka streams. KSQLDB. So the events are here. We are just counting card number, how many events, authorization attempts happened for a particular card number within last 5 seconds. Within last 5 seconds, we are doing it. And then if this is like more than 3 attempts were made on a particular card, then in a particular region, then it's like maybe a possible fraud that we are defining. Create table as select. So it is so straightforward. So we are able to implement logic, business logic, like if more than 3 failure attempts were made on a particular card, then it can be a possible fraud. So when you write such query, then it executes, and there is an abstract syntax tree which is created from, like, it will validate the syntax is okay or not, the engine that I was talking about in the architecture. So if you go to the architecture, you will see there is an engine, and that engine is responsible for parsing this particular query, and it will generate logical plan. And in case you are interested to know about these plans, I have explained in Catalyst Optimizer, one of the sessions that I have taken. So you can just go to Spark optimization session. Here you will find more about plans. Here, this is one, and then second, and then multiple sessions I have taken. So you can just see, I think I have explained this in Spark 3.x features. If you go to this video. So if you go here I have explained what is logical plan, what is physical plan from Spark perspective, but you will get an idea what is logical plan, what is physical plan. Yeah. And this particular query is converted into this kind of code under the hood, and then that executes on the cluster. So this is explaining how overall process works. So I would encourage you to please read this, how the overall query is being executed on the Kafka cluster and what are the steps involved. Yeah, so very first step is parsing the query and creating a tree like structure, like any compiler will do that. After that, there will be logical plan which will be created. If there is a filter operation after join, then why not we first do the filtering and then apply join. So these kind of logical optimized plan will be created. This is optimized logical plan, and then physical plan is created, and then finally it executes the actual code on the cluster. So, but as a user of Kafka KSQLDB, you don't have to worry. It's more about like using SQL to fire queries, and it's high level. But under the hood, it generates this kind of code. So now, if you have anything in your mind, feel free to clarify, but I want to show you, there are a lot of concepts around this, like stream, table, materialized views that we were talking about. So I will focus on streams and tables first, because we already had some discussion, but if you want, I can discuss more. But first of all, let's focus on streams and table. So in KSQLDB, we have a concept of streams and table. So what is a stream? Stream is basically unbounded data, right? So if you have to define, stream is basically unbounded data. Yeah. So stream can be created from a Kafka topic, or it can be like stream, it can be created from a Kafka topic. You can create it, or from existing stream. So if you have to work with system, if you have to work with KSQLDB, then you need to know streams and tables, and using this you can access the data through KSQLDB. Can it be unstructured data stream? So the stream is coming from the, like, there will be some data format that you will be defining when you are creating a stream. There will be data formats, and which data formats are supported? You can have data format like Avro is supported. You can have protobuf. You can have delimited data. So for example, CSV, comma separate value. So it supports JSON. So these are the 4 primarily supported formats. The stream is actually, because we are talking about a kind of structured data primarily, because you will be firing queries. It's like table-like structure that you will see. So under the hood, it supports these 4 formats like KSQLDB. But if you have, so very first thing, like even if you have unstructured data, very first thing we need to identify which sources are you working. So if you can share, then that will help. So most likely you will see the data is semi-structured or structured. If it is completely unstructured like text, then you have to pre-process it and make it more structured, and then you can use this. These are the formats which are supported in KSQLDB as such when you are creating a stream or table. Yeah. So if you have any further questions, you can type on chat or you can clarify. Okay. No. It cannot be voice to text, because then you have to first use the AI deep learning based machine learning models to translate that. And after that, the text data is there. Then based on text data, you have to parse that and look for patterns in the data. You can make it structured or semi-structured and then give it here. So it cannot be voice to text. So voice to text has to be done through NLP or speech to text. It has to be done through machine learning based or deep learning based models. And after that, the role will come here. Okay, these are events, and the events will be generated. Let's say very simple example. If let's say you are working with any mobile applications, events are generated. Like these are very common examples. Like I gave Audi car example. JSON data is very common. Avro is very common. So when events are being generated, these are usually like semi-structured data coming from different devices or sensors or mobile applications, and then they can go into the Kafka, and then we can process. Very common scenario. Login event, fraud, like a fraud example that I was talking about. Yeah. So this is stream. Now another one is table. So table is something which is like it has latest value of a given key. Latest value of a given key. Yeah, table is having latest value of given key. So what is that? We want to understand what is the difference between stream, what is a table. So, you know, like everyone knows, this is my basic assumption that everyone knows what is a Kafka topic. Let's say this is a topic. This is my Kafka cluster. And we have a topic. So this topic is having a cleanup policy. And this cleanup policy, this is a property or config. Yeah. And there are 3 types of cleanup policies. One is called delete. Another one is called compact. Another one is called both. Yeah. So delete means it means that after certain interval of time, or we can even say this is based on time, certain interval of time, or there are other configurations also, but let's discard the events. Let's discard the events. Yeah. So very common example. For example, we have banks. In banks, we have bank statement. There are bank statement, and then we have bank balance. So in case of bank statement, banks, they are keeping data for 7 years, 10 years, like they have to follow the compliance. So they are storing data on Kafka for long term. So after 10 years, I want to discard the bank statement. I want to delete. So I don't want to keep those transactions. Like each transaction is an event, let's say fund transfer that I'm performing, credit, debit, or whatever these transactions are happening. So each transaction is basically an event. And I want to discard these events. So I want to do cleanup of my topic because it is ever growing. A lot of data is coming and I am storing it for long term. I want to discard the data after a certain period of time. So I can do that using delete policy. And similarly, compact policy means account statement, or you can say account balance, bank balance. So it means that we want to see latest value of a given key. So what is a key? Key is customer ID. Key, let's say customer ID. So in case of account balance, we want only the latest value of customer ID of key. So we want latest value of a customer ID is our key, and we want the latest value, that is the balance, account balance. So there are two use cases primarily. If you see, like one is where we want to keep the data and discard it after certain period of time. This is called audit trail. This is kind of audit trail. And this one is actually keeping latest value of a key. So if I go back now, so I was talking about, this is like an abstraction. This is KSQLDB terms, you can say. These are the terms that we are talking about. And in KSQLDB, you will see either you are talking about stream or you are talking about table. So when you talk about stream, it is basically abstraction over a topic. This is abstraction over a topic having cleanup policy as delete. And this is an abstraction over a topic having cleanup policy as compact, in very simple terms. Yeah. So you are keeping only latest value. So in case you have a use case where you want to keep the latest value of a given key, then you will go for table. And if you have a use case where you want to store like audit trail, there are some facts which you don't want to discard. You have to prove the data, or you have to go back in time. You have to replay the events. Then this is like stream. So these are two different things. So now if you move forward, any questions till now? If you have anything, feel free to clarify, but I'm just thinking aloud. These are the two things that you will hear a lot. If you go back to the examples that we were looking at, here we created a table because we want to keep the latest value of a given key. So we want to keep the number of attempts which were made on a particular card. So that's why it is a table. And if you go to other examples that I was showing, here we created a stream. So here we are not keeping the latest location, but we are, for each ride, we are having latitude, longitude, and then distance. Depending on the use case that you are solving, you can choose if you want to create a stream or you want to create a table. Yeah. So it's your decision based on the need and the use case. Yeah. So this is a table because here we are creating a materialized view and we want to keep the latest information for a given ride ID. Yeah. So here you are performing continuous transformation. You just want to do it on the fly and move forward. So this is like, there are a lot of examples. I would highly recommend, please go through this presentation on SlideShare from Confluent, where you will find a lot of use cases related to Kafka streams. Yeah. So here we are creating a stream and we are finding from syslog if there is any invalid user. So this is real-time monitoring, alerting, which can happen. Right? So you are analyzing the data from the log file, and logs are constantly rolling. So new data is arriving and the analysis and processing is also happening on the fly. And then we just discussed about this example. And then there's another very interesting example. So in this particular example, we are talking about users who are basically VIP users, platinum users. So you can easily find out the VIP users by joining these two things. You have clickstream data, you have users, you are joining both the things together, and you're finding, like, let's say someone is visiting your website and you want to find out whether this is a VIP customer or not, right? Because in log files, you will never get to know. In log files, you will have only user ID. But actual, the level of the customer, let's say VIP customer is visiting your website, then actual data is stored in the master data, which is in relational database. So you have to join two different topics or two different streams. So what we are doing, we are joining this users. This is a stream. Sorry, this is a table because it is like something which we want to keep the latest value of a given user. we want to keep that information. So this is a table, and you are joining that with clickstream, which is like currently ongoing data, like facts which are coming. This is a stream and this is a table. You are joining these two things together and finding like if we have to take some VIP action, because you will change your recommendations. Let's say some VIP is coming on your website, you want to change the recommendations based on the profile of the customer, right? So you want to do that personalization. So then this kind of join will be very helpful to you. Similarly, there are other other cases where you want to scale up your existing topics, because in Kafka, if you have a topic with X number of partitions and you have to scale that particular topic, it is not so easy. Yeah, because it will impact the message ordering. So then if you use this kind of statement, create table as select, or create stream as create stream as select, then these will help in scaling up the number of partitions. So let's say this particular stream is built on a topic which is having X number of partition, you want to go to 2X. So you can specify number of partitions here. Or maybe this particular stream is JSON based stream and you want to transform into Avro. You can change the data format. So this is very helpful statement, and it is so convenient, so easy. But the only thing is there will be big data movement. So it will be time consuming. So if you are okay to do it in an incremental manner, it's fine. But if you, let's say, when you are doing data modeling in Kafka and initially did not think about the proper number of partitions, and it happens, so then you have to run this, and then it is going to take some time, but it will ensure that message ordering is not impacted. Otherwise, the message ordering will be impacted. Okay, so we just discussed. Now we are like almost 1 hour is complete, but I want to talk about the hands-on. Actually, we have a blog, and in this blog, you can set up Kafka KSQLDB on your local system. You can follow this blog on medium.com. And here you will find, you can install it on Windows, Mac. So we have all the details given. And after the installation is done, you will run it through Docker. And then you can bring KSQLDB up, and then you can execute the basic commands of Kafka. This is one part. Second thing is you want to implement some use case of KSQLDB. So I had already taken one meetup. I have this happened last year. So this particular meetup, you will find we have discussion around. So I have executed all the steps, because it requires 1 hour to perform hands-on in any meetup. So I have already given that demo in one of the meetups previously. So this meetup was focused more on clarifying things. What is KSQLDB, why KSQLDB, what are the use cases, how it is different from case streams, how it is different from Spark SQL, and then what are the terms, streams versus table. And after that, I would highly recommend just follow this. If you look at it, we are not focusing on schema registry, but we can have a separate session. Schema registry has the schema evolution and so many concepts. So if you just watch this video, you will find a lot of hands-on has been done already. And here I have used Confluent Cloud. So I would highly recommend after this particular meetup, if you go through this, then it will help you. How do we perform the exercises on the local system itself related to KStream? So we have done that kind of data analysis, clickstream analysis, and we have applied windowing in this particular meetup. Yeah. So if you have any questions, you can clarify, but I wanted to share this particular thing, like the background behind this particular video, KSQLDB, and then you can watch this video to learn more about the hands-on. If you want to do it on your own, you can do that. So I will take a pause now, and I will quickly check if you have any questions. Okay. Windowing. Okay, good. So that is a good question. Okay, so what is windowing? I explained it here, but I will quickly talk about it. So when we talk about windowing, data is flowing, data is constantly coming. Twitter tweets, they are constantly coming. Log files, they are being constantly written on the disk or wherever, and then they are keep on rolling. Log files we are like a lot of logs are coming, yeah, log lines are coming in each log file, and events are happening. Yeah. So when this infinite amount of data is coming, streaming data, unbounded data set is coming, let's say we are talking about click. What is clickstream data? Can someone tell me what is clickstream data? What is clickstream data? Anyone? Like, if you want to unmute and say something.
Like the data which keep on coming in frequent interval, like click that is on a like LinkedIn data or Twitter data.
Yeah, when we click on any like a web page, for example, any button or any like we select any click on any link. So clicks, this click streaming data is coming, and click, all these clicks are being captured, and there are billions of clicks happening on internet, and we want to analyze it. Yeah. So if you analyze these clicks, then you will actually improve your website user experience, and you can optimize the flows. So you can find out why visitors are not buying, why they're not getting converted into customers, and a lot of analysis can be done. And there KSQLDB will help you in gaining such insights. So this is our clickstream data, which is infinite data, unbounded data set. Even though I have shown some bounds, but don't worry, it's actually infinite data, and we want to analyze this infinite data. Yeah. So here we are having, this is our moving data, streaming data, and infinite data. We want to understand like how do we analyze the data. So stream is unstructured, coming from stream is unstructured, like stream is unbounded, but window is logical view of the data. It is helping defining the bounds of unbounded data. So you're defining a logical window. Yeah. So when you do that, so then it is going to help you in analyzing the data better, right? So there are three types of windowing which are supported. Very first uh, type is fixed window. Yeah. So you can say, I want to find out after every 1 hour, I want to find out what is the sale of a particular product, right? So in each window. So after every 1 hour, you are finding this particular thing. Yeah. So this is fixed window. There is another one which is called sliding window. Very quickly, I will go to the whiteboard and explain. There are multiple types of windows. There is one called fixed window. And then they have sliding window. And then we have session-based window. Session-based window. So this is my data, and you are doing analysis, and simply you are saying that this is, let's say, 12 p.m. This is 1 p.m. This is 2 p.m. And I want to do analysis. These are some events coming. Let's say these are events related to iPhone purchases. So these are 5 iPhones sold in this 1 hour. These are 3 iPhones sold in this 1 hour. These are 2 iPhones sold. So you can aggregate like this particular product sold 5 times. This particular product sold 5. This is like window, fixed 1 hour window. So you have defined the time, 1 hour window. But in this case, when we have sliding window, so in case of sliding window, this is 1 hour. This is also 1 hour. But let's say you have a use case. Your manager says he or she wants to, manager wants to see, manager wants to see sale of, let's say, iPhones. Yeah. After every 1 hour on dashboard of last 1 hour of last 1 hour on a dashboard, which should be refreshed after every 10 minutes, refreshed after every 10 minutes. So you can say this is my 12 p.m. This is 12 p.m. This is 1 p.m. This is 2 p.m. So after every 10 minutes, you can say this is 12:10. This is 12:10. This is 12:10 p.m. This is 1:10 p.m. This is 1:10 p.m. Yeah, this is 1:10 p.m. So here, this is 1 hour. This one is 1 hour. Window is 1 hour. This one is 1 hour. But this part is 10 minutes. This difference is 10 minutes. So after every 10 minutes, like we want to know like what is the like we want to refresh the dashboard after every 10 minutes. This sliding, this is called sliding duration. This is called sliding duration. And this one is called fixed, like which is window duration, Are we clear with this thing? That there are 3 types, and third type is session based. And session based windows are variable in size because it is based on the variable size window. These are fixed size windows, but this one is variable size window. And this one is actually based on the user session. If you are doing some analysis based on user session, you want to find out how many products are added in each cart in each user session. So you can find out, you can do such kind of analysis. Yeah. Okay. Are we clear with this thing before I move to next one? Indrajit, are we okay? Like there are 3 types of windows. And what is a window?
I got it. But I just want to get if I take an example of the Amazon and so many users is doing shopping. If we are doing on the session based, then it becomes like so many windowing will be coming to the pictures on the session based.
Yeah, you can use window based on the session, and based on the session ID, it will create that, and you can do that analytics based on the session ID. Yes. So e-commerce, it is very common. Yeah.
Thank you. I got it.
No problem. So there is another question. We are running around 30K GPS device vehicles, around 1.5 clients, K clients. Okay. And each customer having 10 to 15 different queries running real time. Okay. Yeah. How could we plan hardware infrastructure for KSQL? So I would recommend, like, there is a reference architecture. So you can go to the website here. You will find a lot of interesting insights. Like if you just open this reference, let's say I go to download now and download reference architecture. If you go to this particular document, you will find how do we do capacity planning. Now you can have capacity planning. You have to think about storage. You have to think about memory. You have to think about CPU, network, and a lot of things. So how do you plan for large cluster, small cluster? What is the definition? Are you doing capacity planning on AWS or Azure or Google Cloud? Depending on your public cloud, or if you are using on-prem, depending on that, you can choose. Even the reference architecture will vary. You can see like which platform you are using. So I would highly recommend you should explore this, because capacity planning is covered here in very well detail. And there is another reference which is there in KSQLDB documentation itself. You will find there is a topic related to capacity planning. Yeah, are we clear, Ritesh? Like here in capacity planning, you will see a lot of details are given related to this. You have to think about storage and CPU and memory and all of things. Okay, great. So if you, yeah, sure, please go ahead. Can we integrate last? Yes, why not? It's very common. And if you have to integrate that, go to connectors. If you go to connectors, you can type Elastics. So you have Elastic Sync connector. That means you can send data to Elastic, and source connector, you can bring data from Elastic to Kafka. So both are possible. Okay. So you should use Kafka Connect to connect with Elasticsearch. And in case you want to see the pipeline, then you can go here. This presentation that I was talking about in slide share. This example actually talks about how do we integrate Kafka with Elasticsearch. If you go back, There is one example. Yeah, this one. So Kafka to Elasticsearch and Kafka using Kafka Connect thing connector. You can do that. Common, very common thing. Yeah. Okay. So if there are no other questions, then we will meet again in the next meetup. Yeah. Thank you. Thank you so much, Indrajit. Yeah. So you will find we have a lot of posts being shared and a lot of articles, cheat sheets, and many other things are being shared here. So you can follow this page. Okay. Thank you so much. And I will see you in the next session. And Handson is there in the clickstream session. So don't worry about it. Just go through that session, perform hands-on. If you're facing an issue, you can just write in the comments and then we'll get back. Okay. Have a nice evening. Bye-bye. Bye.